A 2,000-ton machine is stuck under a mountain, with a kilometer of rock above it. The temperature drops to minus 42 degrees outside, causing the rock to crumble like wet sugar. For 80 days, this machine will not move. The tunnel, intended for 10 years, was finished in 4. The tunnel cuts through the impassable mountain, crossing 16 geological fault zones that threatened the project. One man walked into the tunnel on a January morning and found the walls had moved overnight. Before this tunnel, truck drivers spent 7 hours on the road, facing extreme weather and road closures. The pass sits at 4,280 meters, where ice and snow close the road for most of the year. A dairy farm in the north and a hospital in the south are separated by this 5-kilometer wall.
On December 26, 2025, the wall was finally opened, creating the longest road tunnel in the world.
7 hours became 3.5. The pass itself became a 20-minute drive. But there is a question no one answers up front. How to build this long at this altitude? The Tian Shan is not one mountain, but 2,500 kilometers of folded, fractured, and seismically active crust. 16 major fault zones cross the tunnel's path, with 12 clustered right at the entrance. Picture this. You are the project engineer, with 2 machines and 22 kilometers to cross. Which end do you start from, knowing 12 faults are waiting in the first stretch? The standard way to bore a long tunnel is to run 2 machines from opposite ends. At a normal rate of advance, it would take 10 years. But the region cannot wait that long. The solution had to be geometric, not mechanical. The engineers did not dig 1 tunnel, they dug 3.
2 main tubes for traffic and 1 central service drift between them.
From the surface, 3,000 meters up, they dropped 4 vertical shafts down into the line of the tunnel. Each shaft was a new entry point, and each entry point was a new working face. At peak construction, 14 faces operated simultaneously inside the same mountain. 14 separate crews attacked the rock from 14 directions. The tunnel was built from the inside out. The shaft is the weapon. It is the deepest vertical shaft ever sunk for a highway tunnel. You cannot dig a 700-meter vertical shaft with picks. You cannot blast it. The debris has nowhere to go. The shaft is the only exit. They built a machine specifically for this problem, called the Shouchuang. It descends, it grinds the rock beneath itself, and it lifts the spoil up above it.
A machine like this did not exist before this project. It took 1.5 years to develop.
On-site assembly took 25 days, then it started down. I am standing at the lip of one of those shafts. You drop a stone and it disappears into sound before it disappears into depth. Somewhere down there, a tunnel is being built by men who did not come to work through a door.
They came through a hole in the sky. With the shafts sunk, the main attack began.
2 hard rock tunnel boring machines, one named Tianshan, the other Shengli, Victory.
Cutter head diameter 8.43 meters, length 282 meters, longer than the Eiffel Tower laid on its side.
Each machine is a self-contained underground factory. It drills, extracts the spoil, lines the walls, and ventilates. Tianshan started from the north, Shengli from the south. They had to meet inside a mountain neither operator could see.
Then, the real problem arrived. At this depth, the rock sits under 22 megapascals of ground stress.
What does that number actually do to stone? A piece of rock the size of a fingernail bears 200 kilograms of weight. When a TBM bites into rock loaded like that, two things can happen. If the rock is hard, it explodes. Fragments fly across the working face like shrapnel. This is called a rock burst, the single most dangerous event in deep tunneling. In other Chinese deep tunnel projects, rock bursts have destroyed TBMs and buried crews. If the rock is soft, altered by water, weakened by a fault, something worse happens. The rock flows. It squeezes inward around the cutter head faster than the machine can advance. The TBM jams. The cutter head locks.
2,000 tons of precision steel become a sealed coffin inside a mountain.
The engineers know where 12 of the 16 faults are. How bad the rock is inside them, they only find out when the machine is already in it. One truck leaves the tunnel every 30 seconds, around the clock, carrying crushed rock up and out.
Feel that rhythm. The crushed rock has to keep moving, or the machine cannot move.
Now listen for the moment the trucks stop. And then, the rhythm breaks.
Fault zone F6. The TBM enters a section of altered rock that the early surveys did not show. The cutter head slows. Water starts coming through the face, not in seeps, in floods. 7,000 cubic meters of water in a single day. 3 Olympic swimming pools flushing through an 8-meter hole.
The rock in front of the cutter head turns to mud. The machine starts to drown.
The rock crumbles in your hand. Cold water down the back of your neck. The tunnel lights flicker.
So how do you save a 2,000-ton machine that is sinking in its own tunnel? You do not pull it back.
The rock behind it is already closing in. You cannot go forward. The face is collapsing.
You stand still, and you reinforce the mountain itself. You change what the rock is made of.
80 days. The machine does not move. The engineers do not go home. They drill probe holes forward, through the working face, into the unknown rock ahead. They pump grout, liquid cement, into every fracture they find.
They drive polyethylene pipes filled with foamed concrete into the rock face.
Not dozens, not hundreds, eventually 37,800 of them. Each one a shock absorber. Each one a pressure relief valve. Together, they build a 70-centimeter cushion of foamed concrete around the tunnel. A jacket that absorbs the mountain's squeeze before it reaches the steel lining.
The mountain did not give up. F6. The engineers came back the next morning, and the morning after that.
80 mornings in a row. On day 81, the machine moved. This is one fault out of 16. 15 more ahead. And remember the morning the project engineer walked into? The wall that had moved overnight. That moment is still coming. And all of this is happening 1,100 meters below the ridge. On the surface, it is minus 42. The workers operate at altitudes where oxygen is 30% thinner than at sea level. The machinery loses power. Concrete cures wrong. Diesel gels in fuel lines. Men get altitude sickness and keep digging. The project employs 1,582 people during construction. 80% are from local ethnic communities: Uyghur, Kazakh, Mongol. A young South Asian boy herding sheep below the North Portal watches trucks go into the mountain empty and come out full for 4 years. His father got hired in the first month. Now the question the viewer is already asking. Men get altitude sickness and keep digging. The project employs 1,582 people during construction. Because 1 TBM advances 20 to 30 meters a day in good rock. In bad rock, 0.
And every fault is 80 days of standing still. 16 faults. The math is simple.
Without the shafts, without the service drift, without 14 simultaneous faces, this tunnel takes 10 years minimum. The shafts are what compressed a decade into 4 years. The shafts are the victory.
I am inside the tunnel now. The service drift, the middle one, smaller than the main tubes.
You can still see where the polyethylene pipes went in. 37,800 gray dots in a perfect grid.
Up the wall, across the ceiling, down the other wall. Each one is a decision a person made in January 2023. The wall is a map of 80 days that no one wants to repeat. But a 22-kilometer hole at 3,000 meters altitude is not a tunnel yet. It is a cavity. Now, it has to be made livable. Ventilation first. Can you actually push fresh air 22 kilometers from one end of a tunnel? No. Friction kills the airflow. Exhaust fumes would suffocate drivers in the middle. The shafts are what compressed a decade into 4 years. The shafts are the victory.
Each section breathes through its own skylight, straight up to the surface of the mountain.
The shafts that were a weapon during construction are now lungs.
Then the cold. The tunnel is lined. The road is paved.
Condensation on the walls becomes ice. Ice on the road becomes the thing that kills the first driver. The answer is a layer of insulation inside the lining. The tunnel wears a jacket, so the cold rock of the mountain does not freeze the air passing through it.
The tunnel is warmer than the mountain it was cut into.
Two machines advancing toward each other. Survey teams recalculating the alignment every 6 months from both portals.
When Tianshan and Shengli finally met, they met on the line, on the grade, on the millimeter. And what about that morning? The project engineer. The wall that had moved. The answer is almost boring now, because you have already seen it.
A section of the service drift had shifted 9 centimeters overnight.
When Tianshan and Shengli finally met, they met on the line, on the grade, on the millimeter. The crew added more foamed concrete, more pipes. The wall stopped moving.
No one ever told the public. It happened a dozen more times at a dozen other places. And each time the answer was the same. More pipes, more grout, more mornings.
The question from the hook: why a 10-year project finished in 52 months? The answer is not the machines.
The answer is geometry. By refusing to fight the mountain from only 2 ends, the project could fight everywhere at once.